Hello, welcome to Astronomy Live. Tonight, we're going to be revisiting Comet 45P at its closest approach to Earth, and hopefully this time we'll have a little more success than last night. Seems like the equipment's working better, I don't have as many gremlins in the system, so fingers crossed, knock on wood, things should be better tonight. This bright circle here is actually the bright star Vega, and I just wanted to start this off because there's been a lot of confusion lately about Venus and trying to take pictures of it excuse me, with normal consumer cameras which don't know how to focus for astrophotography. Autofocus mechanisms on most cameras are really bad at trying to focus on small bright dots in the sky. That's not what they were designed to do, and so you end up usually with images like this. This is an out of focus star, but any bright point-like source of light will produce this in a refracting imaging system. So I've got the SBIG ST-2000XCM currently set up on the Orion ST-80 refractor, riding piggyback on an 8-inch MEDALX200, and I'm about to focus it. All these little circles here, this is just dust in the camera system. This is going to happen anytime you've got a camera and a lens. There's just no keeping all dust out of it, and it will show up particularly well when you have a bright out-of-focus object like this. So I'm going to start imaging it now and try to focus it. So you'll notice as I bring it into focus, you can start to see dimmer stars that were too far out of focus to see before. And there we go. That's getting close to focus. Now I'm going to increase the resolution of the pictures, go to 1x1 binning, and focus in on a particular section of the image, and continue focusing. Oh, that's taking it further out of focus, which produces its own sort of interesting colors and shapes, doesn't it? Okay, I might have gone past focus on the other side. That's actually really close to correct focus there. Okay, that's pretty good. Okay, let's turn off subframe. All right, we should be in business. I've got the main telescope centered on Vega, which is this bright blue star, and the refractor is pretty close to being centered. So we'll call that good enough and move on to the comet. And before I do that, let me just pull up the chat here and just be able to monitor that as we go forward. And right now, in the next few minutes, is when the comet will actually reach its closest approach to my personal location. Got to charge the battery, John Lynch asks. Yes, recharge the batteries. And the problem last night was not that the batteries were discharged, it's just I don't have enough batteries for the amount of equipment I've got. Well, I guess one problem was that I didn't have the laptop charged. I thought I did. So I had to plug it in. And right now, the laptop is running off its battery, which will drain it pretty quickly, but should give us about an hour of broadcasting time. Okay, let's see if this works. I'm going to try my tracking software again. This may or may not work. Let's see how we do here. That high-pitched beeping is the telescope's computer telling me that it's slewing, it's moving. I'll shut that off in a minute, but I just need that for diagnostic purposes here for a second. So apologies, just bear with it, hang tight. And let's start a 5-second exposure on the comet, hopefully. Because right now is when it's reaching closest approach to my location. Is it there? Is it there? That might be it. Okay, let's do 30 seconds. I'm not going to shut off the beeping yet until I verify that the comet is being slewed to properly here. Also, I've hopefully fixed the internet problem. It should be a more stable connection tonight. I apologize profusely for the audio and visual problems last night, but hey, it was a practice run for tonight, right? Yeah, this looks like... yeah, that's it. There's the comet. We have ourselves a comet. Comet's right here. Telescope's tracking properly. All right, I'm going to shut off that awful screechy noise. All right. Okay. We're going to stop this. We're going to start saving the pictures. We're going to go to 1x1 binning. And we're going to do, let's do 2-minute exposures and just see how it goes. So right now is when the comet is actually at its closest approach to my personal location. It's not quite the same as the comet's closest approach to Earth due to Earth's rotation. So the comet actually has already reached closest approach to Earth, and it's now starting gradually to recede from Earth. The closest it got is about 0.08 astronomical units and change, or a few million miles, about 7.6 million miles. And now it's starting to head away a little bit. To put that into perspective, it's, I think, about 32 times the distance to the moon, somewhere in that vicinity. But because of Earth's rotation, from my personal location where the telescope's located, it actually continues to get a little bit closer for about an hour and a half after it's already reached closest approach to Earth, because Earth's rotation is carrying me towards the comet faster than the comet is receding from Earth. So we've now reached the point where the comet's velocity is going to start to take over, and it's going to start to recede from my location. It's not going to be fast enough that you'll notice it shrinking dramatically or quickly or anything like that. You probably won't notice any difference in the size of the comet between the start of the webcast and the end of the webcast, but it's just kind of cool to know that this is it. This is the closest it's going to get for this approach. And this is one of the closest comet approaches to Earth in our lifetimes. It's not the closest, and there have been others recently in the last few years that have come closer, but still. Let's see, if I remember right, it's like the 10th in the last 100 years. Let's see here. I'm just pulling up the list of closest cometary approaches to Earth. Okay, so we're downloading the light now. And there we go. Hooray! Okay, it's now going to take a 2-minute auto dark exposure. So the comet is right here near the center of the picture. And these circles here and this large fainter circle, these are all dust spots on the CCD or on the CCD chamber window. that produce these. And at the end of the night, what I do is I take flat field exposures to calibrate these images and take those out automatically. So you take calibration images by pointing. The easy way to do it is to point at the sky during twilight and take pictures with the camera. When it's bright enough that you don't see any stars, you just see sky glow from the morning twilight. Not so bright that it washes out the camera, but not so dim that you can still see the stars. You take a bunch of pictures that way, and all you have in those pictures are the dust spots. You then load that into a stacking program like Deep Sky Stacker as flat field images, and it will automatically calibrate that out. It'll compensate for the loss of light here in these spots and flatten out the image so that you don't see the dust spots. So the final images, which I'll put into the video description after I'm done processing them, will not have any of these terrible spots. But the pixels, the bright, colorful pixels, are hot pixels, and that is going to be taken out in 30 seconds by an auto dark exposure, which it's taking right now. So I know you guys can't see the camera control window, but we've got now just 20 seconds until that arrives, and then it will start taking the next picture of the comet. And the telescope is actively tracking the comet based on its orbit using a program that I've written and I'm currently developing. So stay tuned for updates on that program because I will be releasing it publicly in the near future. I've got a bug that I need to squash to do with the satellite tracking function, but the minor planet tracking function is working great, and the sort of rocket tracking and unknown object tracking functions working great too. So provides additional tracking functionalities for older telescopes like my LX200 Classic that haven't existed before. So kind of cool. So yeah, we've got a great picture here of the comet amongst all these stars. And let me zoom out for the big picture overview. So the comet is just this faint fuzzy glow right here. It's too dim to see by eye. It's probably around magnitude 7 or so, but that sounds pretty bright for the telescope, but really the problem is that sorry, I seem to be missing my, that's weird. Okay, well, no big deal. But the problem is that the light is spread out over a wide area of the sky. So if you try to look at it with binoculars, you'll probably be able to see it. I can't see anything in that area of the sky by eye, and part of that's because, well, you've got a full moon out tonight. Earlier tonight there was a penumbral lunar eclipse, but I didn't get a chance to see it or track it. I was sleeping to prepare for this webcast, and my batteries were literally recharging for the telescope as well. So everything's charged up and ready to go now. But earlier tonight there was a penumbral lunar eclipse, so there's a full moon out now that's washing out the sky with light. So even if it is closer to magnitude 6, which I doubt, it's probably closer to magnitude 7, which is really, I mean, you have to be an experienced observer with averted vision under perfect skies to see anything that dim. Even if you were, you wouldn't see it because there's too much moonlight out tonight. So it's a telescope and binocular target only. The advantage of binoculars would be that you'd be looking with less magnification, so the light would be condensed into a smaller area, so your eyes might be able to see it, but I think it might be tricky. So yeah, we're tracking on the comet here. The stars are going to streak by. That's expected, but the comet will remain as a stationary object in the image. So got the active tracking working great tonight. That's going to be awesome. It'll make life so much easier for stacking these photos and for putting them together into an animation where the comet's actually stationary at a fixed point in the image. So it looks like my last video from last night went kind of viral suddenly. I went to bed and it only had about 800 views. It's now suddenly got over 5,000. I don't know where all that came from. I don't know who's linking to my video, but somebody must have linked to it. I hope they link to this one because tonight is going to be so much better. Oh, Sean Hufford asked, after I get a few shots, can I flip through them to check for visible motion against the background stars? Yeah, now you see, now the stars are streaking by, so now you see the motion. Where is it now? Well, let's see. According to my program, oh, is it not updating the coordinates? No, it is. Okay. The current position is 16 hours, 37 minutes, 24 seconds right ascension. Declination 25 degrees, 41 minutes, 13 seconds. And that's at the equinox of date. In terms of where that is in the sky for anyone who's trying to star hop to it or whatever, you really need to print out your own star charts with the stars and everything. But it's in, looks like it's in the constellation Hercules. Yep, it's in Hercules. The closest star looks like 39 Hercules. But you kind of have to print out your own star charts to see exactly where it is. But yeah, it gives you a general idea of where you can expect to find it. So let's see here. Looking through the list of the closest comets in the last century. Now, if you look over human history, over recorded history, you can find tons of close approaches to Earth of comets. Comet Lexell, Halley's Comet, Tempel-Tuttle, etc. But if we just look at the last century, looks like the closest was P 2016 BA14 Pan-STARRS, and I'm getting this off the Minor Planet Center website. Then we have IRAS Araki Alcock, sorry if I'm mispronouncing that, in 1983. Then we have 252P Linear in 2016. So let's see, let me just count here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it's going to be 10. It's the 10th closest comet approach to Earth in the last century right now. So, Hale-Bopp was, let's see, was Hale-Bopp even on this list? No, it doesn't look like Hale-Bopp even makes this list. How close did Hale-Bopp get to Earth? Close approach date, 96. No, it didn't get all that close to Earth according to this. I'd have to look up the exact number. It doesn't even show. It doesn't even make the table on JPL's website. But its minimum orbit intersect distance was 0.11 astronomical units, which is considerably further than the close approach of this comet. And of course, it didn't. Its close approach to Earth is not the same as the Lloyd. I'm not going to chase that rabbit hole too far, but might be something interesting to look up later. It was a huge comet, yeah. Hale-Bopp was fantastic. You know, I think everyone, even people who aren't all that interested in astronomy, if they were around back then, they probably remember seeing that comet. It was my first comet that I really saw. I was around for Halley's Comet in the 80s, but I was too little to really remember that experience too much, except that it was cold. Maybe it wasn't cold. I don't know. I was a little kid, and I just remember being agitated by my parents dragging me outside to see this thing. I'm like, I don't see anything. Like maybe I saw a little fuzz something. I don't even think I saw anything. But Hale-Bopp I distinctly remember and being impressed by in the binoculars, and I got my first telescope around that time too. I wouldn't say it's what got me into amateur astronomy, though. The thing that really hooked me was Saturn. For the first time, seeing Saturn in the telescope and seeing the rings. That's when I was hopelessly hooked. Just make sure. Just going to double check here and make sure I've got it saving the images properly. Don't want to goof up on that. Yep, all coming in good. How are we doing on battery usage? I'm going to lower my screen brightness here to conserve battery power. We have an hour and 8 minutes of power remaining estimated. That should take us into astronomical twilight. Maybe even past astronomical twilight at that point. Yeah, Hale-Bopp was 96 and 97. I remember seeing it in December of 96 and then made a move to Colorado and saw it after I got settled in there in early 97. So, how's the audio and the video tonight? Can someone in chat just let me know if there have been any interruptions in the audio or the video? I think it should be solid tonight. I have a better connection now. But Sean, if you're there, can you let me know if you've seen anything odd? Frank says goog. This is good. Great. Okay, good. Good. Yeah, there's a power inverter sitting right behind the microphone. There's nothing I can do about that. That's responsible for the hum. In fact, it's actually vibrating the whole table. Everything is sitting on here. It's kind of, if I let my hand rest on the table for too long, it kind of numbs my hand. So there's also a gutter a few feet away that's draining some water back there, and it's making a little bit of a noise. But at least in terms of connection and everything, everything's solid. So yeah, if you're just joining us, we're imaging Comet 45P at its closest approach to Earth tonight, and it's now past that close approach, and it's slowly receding from Earth, and you can see it as the cloudy object right here near the center. All the stars are streaking by. The telescope is actively tracking on the comet. It's being imaged with a SBIG ST-2000XCM on an Orion ST-80 refractor, which is riding piggyback on an 8-inch Meade LX200 Classic. So just for programming update purposes, after the webcast tonight, sometime later today, I'll get to work on processing these images and upload them as a time lapse of everything recorded tonight, and stack the images too if I can, because we might increase the screen brightness here for a second. Well, maybe not. I don't know. I mean, I'm almost seeing what looks like it might be the start of a new tail. The comet lost its tail at its closest approach to the sun, but it might reform. I don't know. Hard to say. This could just be a couple fuzzy objects from deep sky objects that are streaking by, and it gives it sort of the impression, if you, I don't know, almost like an illusion of a tail. But it'd be easier to tell once I stack the images. When you stack the images, you average the pixels over the course of all the exposures. So each exposure here is 2 minutes long, and then you average all of those together, and anything that changes, like noise, gets averaged out. But anything that stays the same between the images is retained and strengthens the signal. And so anything that's just barely detected, like maybe the faint forming of a new tail, would come out in that final stacked picture. So I'll put that stacked picture together and put that into a link in the video description here, as well as possibly putting it into the end of a time-lapse video that will be posted sometime this weekend. So come back for that. If you like what you see here, please, subscribe to the channel, and this is what we do here. I like to get the scope out, especially for any special events like this, and provide live images of it for you all. Oh, my pleasure. My pleasure, Kaiser Cube. Thanks, Bacon Bits. This is how I roll, yeah. Yeah, I took a look at Saturn last night before I did the webcast, and it looked nice. The eyepiece of the telescope. Speaking of the eyepiece of the telescope, I'm going to go cheat. I'm going to go over to the scope and see if I can peer through the main scope, which is currently unoccupied. We're imaging here through the wide field refractor, but the main telescope should be pointed at it as well, and I've got an eyepiece on there, so I'm going to take a quick look. Hopefully I don't shake this image too much. I'll try not to. In fact, what I'll do is I'll wait for the image to complete, and once it starts downloading, I'll hustle over to the eyepiece and see if I can sneak a quick peek at the comet. It's too difficult. Too tricky. I hope I didn't bump the camera at all on this exposure, but tried to be careful not to bump the camera with my head. There's not much clearance between the camera on the refractor and the eyepiece on the main telescope, so it's a little too difficult to sneak in there right now and sneak a peek. See if I can rearrange things on the main telescope real quick after this exposure finishes. Yeah, sorry, I muted the audio there for a bit while I opened the close-up cases, and there was a dump truck taking something away across the street there that was making an awful racket. But yeah, I'm just getting ready here to sneak in a new eyepiece on the telescope as soon as this exposure completes, so I can try to sneak a quick peek through the main telescope while the refractor here takes these pictures. But I have to do it between exposures while it's downloading the last image, so I don't shake one of the pictures it's taking. So I only get to manipulate the scope for a few seconds every 2 minutes. It's kind of ridiculous. So we're running 2-minute exposures here. And the next one's about to complete. Okay. Alright, got that eyepiece in just in time. Okay. So, yeah, somebody was asking about the lunar eclipse. There was a penumbral lunar eclipse last night. Yeah, penumbrals are not really all that exciting to me either. I'm kind of over those. It's like, yeah, you get a penumbral eclipse for free anytime you get a total lunar eclipse. But the comet's more rare and exciting, I think. Everything shifted a little to the right. Oh no! Okay, well, that'll be a... I guess I did bump the scope a little bit. Alright, well, sorry. That'll make for an interesting anomaly in the time-lapse. Somebody will watch the time-lapse video without seeing the broadcast and say, why did it shift? The Earth shifted. No, I just bumped the scope. I'm going to try to shift the eyepiece in between exposures here so that I can get at it without bumping the scope or the camera. The next picture should finish up in 15 seconds. Yeah, someone's going to say, it's CGI. It's fake. It's a fake. Senator Vredak, Romulan expert. Yeah. Conundrum. It occurs to me that while I have now put on a new eyepiece, I didn't think this through very well because I have to focus that eyepiece. And the time it takes to download the pictures is not much time to get up to the eyepiece and focus it. This could take a while. This was not the best plan I've ever come up with. I really don't want to stop the exposures, even for a moment, though. I don't want any kind of interruption, because that'll be even more obvious in the time-lapse. Even if I only stop it for 30 seconds, you'll notice how the stars seem to skip position. As it is, there's going to be a little gap between each exposure, but at least that gap is consistent. If it becomes inconsistent, that looks weird. So, don't think I want to do that. Just going to try some trial and error here, mostly error, on focusing in between exposures. You would think after having the scope all these years, I would know which way to turn the focusing knob when switching between one eyepiece and the next, but honestly, I do so much photography these days that I don't normally use the eyepieces all that much, except to set up the telescope, so actually don't know which way to go with the focusing knob. I really should know that. Yeah, this is an image from my telescope. So this is being taken with an SBIG, that's Santa Barbara Instruments Group, ST-2000XCM on an Orion ST-80 refractor, which is riding piggyback. Literally what it sounds like, it's riding on top of a Meade LX200 Classic, which is providing the tracking. So software I've written is providing the tracking commands to the telescope so that it is tracking the comet based on the comet's orbit. And then the refractor is hitching a ride on top of the telescope where the pictures are being taken. And that provides a wider field of view. If I had it on the main telescope, the view would look more like this. You would just see sort of this section here, which I suppose some might say that's advantageous, isn't it? Because, you know, you're zooming in on the comet. But really, the problem is the more you zoom in, the more the comet's light spreads out. And so you need a longer and longer exposure to see the same brightness of the comet in the picture. And so for a coma that's as large as it is, especially considering how close it is to Earth, it makes more sense to actually take the picture with a wide field telescope. Also, if there happens to be any kind of reforming tail to the comet, you're only going to really be able to pick that up by taking exposures with a wide field refractor. You might miss out on that if you try to image it with the main telescope. So if anyone's wondering, that's why I'm not using the main telescope to take these pictures, because we want the wide field view to maximize the f ratio, or the speed of the imaging. So I'm taking 2-minute pictures here, but if I were shooting this through the main telescope, I'd have to be taking at least pictures that are twice that long, if not more. And we'd have a lot fewer pictures and a lot bigger of a delay between pictures. So, bottom line is that when you're doing amateur astronomy like this, it's not really one size fits all. You gotta have the right tool for the right job. How many megapixels are on the camera? Not that many, actually. It's only a 1600 by 1200 image. But that camera originally retailed for $3,000, and it's still worth a fair chunk of change, because it's about the technology that's on the camera, not just about the megapixels on the camera. And really, you want the right number of pixels. You want the right size of pixels more than you're concerned about the number of pixels. Sorry. So you don't want to drastically oversample the image past the useful resolution of the telescope. So you don't want really, really tiny pixels. You're really concerned about the physical size of the pixels on the CCD. And you want to match that up nicely to the focal length of the telescope and the resolution of the telescope. And you're also concerned, depending on what you're doing, about things like thermoelectric cooling. So right now, this camera is actually actively cooling its CCD to a set point, minus 10 degrees Celsius. It's actually holding that CCD at that temperature, which is kind of impressive since this is Florida, you know. I mean, it's what we consider a cold night in Florida, but this is still, this is about 25 degrees Celsius below ambient temperature, and it's holding that temperature without any trouble at all. It's only at about 50% cooling power. I could crank that up even more if I wanted to. So it's holding a really cold temperature, which reduces the noise on the CCD. Very important, because again, you're more concerned about things like noise in the image than you are the number of pixels, because you're taking these pictures of really dim objects even with really long exposures, like 2 minutes. It's still a very faint object, and so you want to maximize the signal by minimizing the noise. And also, if you're doing photometry, and you're trying to monitor an object over time, if you're, say, looking for a transit or something, you want to minimize the number of variables. And one of those variables is the temperature of the CCD. As that changes, the response of the CCD to light changes, the noise level of the image changes, it affects your photometry. So to do accurate photometry, You can do it with an SLR camera that's not cooled, but there's caveats, and it's trickier. It's a lot easier when you can hold the CCD at a set point and keep it there. So it's useful for that as well. And then finally, this camera has auto-guiding capability, which I'm not using right now because I'm actively tracking on a comet that's moving. But normally, if I'm taking a deep space image of some nebula or some galaxy, I want to be able to take a very long exposure, even longer than this, 5 minutes, 10 minutes. And to do that without getting any sort of tracking errors in the telescope from the motors, you do auto-guiding. And so it's got a built-in auto-guiding chip. So even as it takes these pictures here, it's got a second CCD built into the camera that can simultaneously take pictures of a guide star and provide guiding commands to the telescope. So it's all very useful technology for amateur astronomy, and that's why it's a very expensive, very high-tech camera. So the resolution, people usually scoff at that, but it's actually a nice fit in terms of the size of the pixels to the camera or to the telescope. Yeah, it would be nice if there were more of them. It is an older camera, but it's actually really nice. It's actually not too bad, and it takes some really nice pictures. So yeah, there's a term for SLR noise. Well, there's different kinds of noise in any CCD, including SLRs. There's bias noise. There's read noise. They're generated in different sorts of ways, and I'm not an electronics expert who could tell you exactly how that comes about, but there are different ways of calibrating it too. So you can take bias frames, which are very short exposures, like minimum exposure length pictures, and dark frames, of course, to cancel out the thermal noise that builds up in the image. But even in calibrating it, there's still sort of a background noise floor, and the warmer your CCD, the higher that floor is going to be, and so the stronger the signal has to be to just get above the floor. As long as you get a signal, yeah, you can stack and stack and stack the pictures until you get the signal really strong in the stack. But if you're going for something really dim, or really dim features of an object even, it's possible that it may not get above the noise floor if your CCD is too warm. And then there's also the issue that your dark frames, because they include thermal noise, they have to be taken at the same temperature that the CCD was operating when it took the picture. The problem is, if you're doing, and I've run into this before myself in trying to do SLR photography, if you're taking pictures throughout the night with an SLR camera on the telescope, at the end of the night, you say, okay, I'm going to take some dark frames now. You take your dark frames. Well, guess what? You're dead in the water, because those dark frames are not at the same temperature that the CCD was at the beginning of the night. That temperature varied throughout the night as it cooled off, and then maybe it used up so much battery power it started warming up again. It's this weird biphasic function, and it's not entirely easy to predict. I had it before where I tried to take dark frames at the end of the night just as twilight was hitting, and the darn thing started warming back up as the sun approached, and the dark frames were useless. They didn't really calibrate the images, and I just banged my head against the wall. So it's really a bit of a nightmare to work with, compared to this anyway, where it's stupid easy. You just set it to the set point, and you know exactly what temperature it was at when it took the picture. It records that. It even records that in the FITS header data. It's like the metadata for an astronomy camera. They save them in a FITS format. It's not the same as EXIF. It's a different type of header, but it serves the same purpose. And one of the things it actually records is what temperature the CCD was at. So you can look back at the header data and know exactly, here's the exact temperature out to the decimal point of what the CCD was at when it took the picture. And so I can calibrate that perfectly. So, yep. Oh, no problem, Kaiser Cube. I'm glad I was able to do it. It's perfect weather for it. It just worked out nicely here in Florida. So, Death Reaper, we've got the comet in view here. It's this cloudy object right here. And ignore the dark spots. These are dust motes. They will get removed when I do flat field subtraction after the webcast. The comet is being actively tracked by the telescope, so the stars are all streaking by. The stars are all streaks, but the comet is stationary in the image because the telescope is actively tracking on it. So it will remain more or less stationary throughout the images while the stars will streak by. So it's too dim to see by eye. You definitely have to be using at least binoculars. And I don't have, I should start carrying binoculars with me again. I don't have any with me at the moment, I don't think. I'd be curious to see if I can find the binoculars, but yeah, it's too dim to see by eye for sure. And even the binoculars, I think with all this moonlight, it would be a challenge. It might be doable, but yeah, it's binoculars and telescope only for sure. Can't they see the comet from ISS? Not really. Not really. I mean, they could probably, I'm sure they could easily photograph it from ISS. Cameras can pick up more light than our eyes can. But at magnitude 7, you got the moon. I mean, even from ISS, you're going to have moonlight coming into the window. So if you're sitting in the cupola, let's say, I mean, maybe you could get it at the right positioning so that the moon's kind of behind you and the station's kind of shielding you from the moonlight, maybe. But you're going to have moonlight reflecting off the Earth, which is surprisingly bright. At least, it's bright even in camera pictures taken on a full moon night like this from ISS. Take a long exposure photo. You can see the stars, but you can also see the Earth shining down below from all the moonlight. So you got that to deal with. And the comet is pretty darn dim. It's around magnitude 7, maybe. So it's at the limit of human vision. And yes, you have no atmosphere to speak of that you're dealing with. But atmospheric extinction at visible wavelengths, especially when it's this close to the zenith, it's not all that much. So you're not going to gain much of an advantage. I'd be really kind of surprised if they were able to spot it from ISS. I mean, maybe if you really sat there and worked hard to get yourself dark adapted, sat there in the cupola, made sure all the lights were off, made sure the moon was being shielded so that it wasn't coming into the windows, and got it just right, then yeah. Oh, we've got a satellite passing through that picture. That's cool. There's a satellite streak right here. Let me see if I can identify that. Yep, okay. Hold on. No, no, come back. Yeah. Come on. There you go. What are you? Ah, okay. That was Global Star M001, according to Sky Safari Pro. Its altitude was 1,515 miles. So, it's cool. Yep. That's exactly what that was. It passed right through the stars that Sky Safari Pro shows it passing through. Exactly the right trajectory. So that's definitely what that is. Global Star M001. So, I tell you what, I can't recommend it enough. Sky Safari Pro. If you're an amateur astronomer like me and you do astrophotography like this, and you have a smartphone or a tablet, anything like that, get yourself Sky Safari Pro because it is so handy. It's nice that, to me anyway, it's nice to separate it out from the computer so I can leave the computer running here with the CCD window open and all that stuff, and I don't have to fiddle with it to pull up my planetarium program. I can just look on my phone or my tablet, whatever, and it's got all the power of a desktop app, really, in terms of what it does for you in terms of planetarium software. So just really, really handy. And no, full disclosure, I do not get any kickbacks from from Southern Stars or Sky Safari people for recommending their software. It's just a personal recommendation. Honestly, this app has paid for itself in terms of how useful it is. Is this a first for me with Comet and Sat transits? No, no, probably, almost certainly not. No, it wouldn't be. You get satellites all the time at this time of day. So if you have an early morning comet like this, it's pretty much inevitable that at some point a satellite will fly through your field of view. I can't think of, I couldn't think of a particular image I could pull up right now that shows this, but I know I've had it before. It's a routine sort of thing. It's so routine that I can't pick out any particular specific instance like this, but I know it's happened. It happens all the time. So, what are those two dots to the left of the comet? So these, I'm assuming you're talking about the black circles here. These are dust motes on the CCD. So they get removed in the flat field process. So after I'm done with Webcast, what I do is I leave the telescope set up, and wait for twilight to get bright enough so that you can't see the stars. You get it before the sun comes up, when the dawn sky is still dim enough that it doesn't completely wash out the camera. But you wait till it's bright enough that you can't see the stars anymore, and then you take pictures, and all you have in the picture then is the blue dawn sky and these dust motes, and you upload those as flat field files, or not upload them, but you use them as flat field files to calibrate these images in Deep Sky Stacker, and it takes those right out. It's like magic. Just eliminates all the dust on the CCD, and then you have nice clean images. So that's the process these images will go through after the webcast today. Just to point out Sean Hufford says, just to point out, Al, I think the stars that were even horizontally at the start have now moved out of the top of the frame. You mean the stars that were visible at the start of the webcast have now moved out at the top? Yeah, I'm sure they probably have by now. It's been 48 minutes since I started taking pictures, roughly. Even with the comet, yeah. The stars that were even with the comet, yeah. Yeah. And I think we've now started into astronomical twilight. Let's see. Yep, astronomical dawn was about 4 minutes ago. So the images will slowly start developing this background light that will get brighter and brighter. You may not notice it yet, but it becomes noticeable even at this point when I do the processing on the images. After I flat field subtract them, if I look at them in a contrast enhanced mode, I can start to see it almost right away, which is kind of interesting. And then nautical dawn will be at 6:17, and by that point, you'll really see it strongly in the images. It'll pretty much be washing out the comet probably. So within the next 20 minutes or so, that's when we're going to have to wrap up the webcast. We've got 44 minutes of power remaining, so it's working out nicely. Yeah, the comet lost its tail. Will it get it back? We don't know. It's not really. It's kind of a mystery. We'll see. And who knows? I mean, maybe it's already starting to reform a tail. It's possible. But it'll be easier to know, easier to tell once I get the images stacked. And we'll see what we've got to work with there. And I hope everyone got to see the stacked image. Well, it wasn't really a stack, it was a time lapse of images from last night's webcast. I know that webcast was just problem ridden. It was just riddled with problems, but even so, you know what, let me pull up a window here and I'll just share the time lapse from last night. The one from tonight will be so much better because I got an earlier start here. Got more time on the comet before astronomical twilight, and so in fact, I think we started off at astronomical twilight last night after all the problems I had. But so the one from tonight will be so much better. The exposures are longer. We're actively tracking on the comet, etc., etc. But even so, the one from last night's kind of cool. I'm pulling that up now, and I'll just share that real quick with you guys so you can see. Yeah. So this is the time lapse from last night's images. You'll find that link in the video description of last night's webcast if you look there. So the comet, you can see it's moving here. I was just tracking on the stars. The focus wasn't quite as tight, and didn't get very long on the comet, but there it is. It looks like the comet fades out because actually it's complicated, but the processing I did normalizes the images to the background light level. So it was really the background light that was getting brighter. The comet was not getting dimmer. And then the way that I processed it also made it seem like the stars were brighter, retaining more brightness than they actually were. That's like the whole processing pipeline that I do. That's worthy of its own video. That would take me an hour to explain, but That's why it looks kind of funky like that. Oh, we've got another comet another satellite going through here. And this one, there's some variation in the brightness here. I bet you anything this thing's a rotator. Uh, that is to say, it's a rotating satellite, probably a dead satellite. Let's see what we got here. See if I can figure out what it is. Huh. Nope. I don't see it listed. At least SkySafari doesn't list this one, which probably means it's space junk. Like I said, there's brightness variations in it here. It's like it disappears here and then it comes back here. It's like turning on and off. It's not really turning on and off. What's happening is it's rotating, and at certain angles it reflects more sunlight, and at other angles it doesn't reflect as much. And so it's a very rapid rotation. These are, again, 2-minute exposures, and it passed right through the exposure, probably in just a matter of seconds. And even over the course of that, it's like completing rotations here. So it's a little piece of space debris, probably. It's interesting. So SkySafari doesn't list that one, but its catalog is not exhaustive by any means. So to identify this, what you would have to do is you'd have to do astrometry, solve the positions of the stars, like I showed in the previous video. The SDO video is a good example showing how to do that. And then you get the coordinates along this streak and compare them to where all the satellites were. You'd have to have a complete catalog of all satellites, which SkySafari, unfortunately, is not quite complete. Not to mention classified satellites, which I do not think SkySafari includes the classified satellites, but you can find the orbital information on classified satellites courtesy of amateur astronomers. Mike McCants keeps a catalog of classified satellites on his website. So a mystery satellite for the picture in that one. Can you see it in Australia? Yes, you should be. Well, depends, actually. Declination's getting kind of high now. It's a question of whether you can see up to 25 degrees positive declination. I should know. I don't know. Let's see. Let me just tell it here. Let's pretend I'm in Sydney. I mean, you can't see it right now. It's below the horizon, but could you see it later? Yeah, you should be able to see it later. Transits. Yeah, you should be able to see it. It's not going to be that high from Australia. You know, you're going to be looking at, in the case of Sydney here, just before twilight sets in, about 16 degrees above the horizon, 17 degrees above the horizon, somewhere in that range. Which, you know, is not great compared to what it could be, I guess. But yeah, theoretically, you could see it. From here, just to give you some perspective, it's currently 68.5 degrees above the horizon from my location here in Florida right now. So it's definitely favorable for northern hemisphere observers. But yeah, You can technically get it from Sydney or Australia, I suppose. Yeah, it's below the horizon right now, but before dawn, if you wait till shortly before dawn, and I mean really just before dawn, you'll get it just above the horizon, around 15 degrees or so. How long will it go on until it's not visible anymore? Oh, it'll be visible for a while. Uh, let's see. Let's just take a look at this. Let's see here. Let me change some stuff here. That's not what I want. Yeah, I mean, looks like it's pretty well visible for the rest of the month. It'll be somewhere that we can get it, maybe even past that point, from here in the northern hemisphere. But it's going to be getting further away and dimmer from this point. But this is a periodic comet. It's important to point out, and it was not that long ago, about 21 years ago or so, that it made an approach to the sun that was actually captured by the SOHO spacecraft. So there are SOHO images of it from, I think, 1996. And let's see, its orbital period is 5.26 years. I actually don't know when the next close approach is. I don't think it's for quite a while. But let me look that up on JPL real quick. I'm curious. Yeah, the next close approach to Earth for this comet isn't until 2032. And at that point, it'll only be about a third of an AU from us, give or take. Oh, starting to see the Twilight there, Sean? Yeah, I haven't really been paying attention to it, but I bet you are. Especially if you watch closely from image to image, it'll get brighter and brighter. Yeah, unfortunately. We're coming up pretty soon here on the end of the webcast. But this has been a really good night. Things went smoothly, knock on wood. Thanks, Kaiser Cube. I hope I can get. I'll try to at least get the time lapse up by tonight. Um, I can't promise that I'll have the stacked image available at that time yet. That actually takes a little longer. You have to be, even with these images where it's actively tracking on the comet, you have to be really careful about uh, stacking them so that it's aligned properly. But excuse me. But I should hopefully be able to get that up sometime this weekend. And also, next weekend, I think it's still scheduled for Saturday, SpaceX is supposed to launch a Falcon 9 rocket from Pad 39A for the first time. This will be the first launch. I believe this will be the first launch from Pad 39A since STS-135 in 2011. And Pad 39A is a historically famous launch pad because that is the launch pad where all the moonwalkers left Earth. So Apollo 11, 1969, first landing on the moon, that's where that launched from, was Launch Pad 39A at the Kennedy Space Center. And many of the shuttle missions launched there too, either from 39A or 39B. And Pad 39A is now leased out to SpaceX. And due to their little oopsie blowing up Pad Slick 40, they are now setting up to launch from Pad 39A while they repair on the exploded launch pad. So this will be their first launch from that launch pad on Saturday, not this Saturday, but next Saturday, to the International Space Station for a cargo mission. So Dragon capsule is supposed to blast off from there about a week from now. And if all goes according to plan, I do plan to head out there to try to track that rocket. It's supposed to be a daylight launch, and it looks like they got the grid fins on for landing, so hopefully they'll come back and try to land it at the Cape, because that would be really awesome to be able to catch that. So Mike Knight, so we're watching Comet 45P, and it's the fuzzy object right here. We're starting to get morning twilight now, so we'll be wrapping up the webcast soon, unfortunately, in the next few minutes as twilight sets in. But the comet is this little fuzzy ball right here, and the stars are all streaking by because the telescope is actively tracking on the comet using software that I'm developing for tracking fast-moving objects, whether it's comets, asteroids, rockets, satellites, all that stuff. So it's performing open-loop tracking right now, but the real special sauce of the program is that it's also capable of closed-loop video-based tracking of fast-moving objects like comets, or not comets. I mean, you don't need closed-loop for comets, but things like rockets, things that you're trying to track that are moving quickly, but you don't necessarily know ahead of time where they're going to go. In this case, we know exactly where it's going to go because we know the orbit of the comet, so we can just track it based on the orbit, which is what it's doing right now. It's called open loop tracking because input's going into the telescope and the output coming out is just the images, but these images are not being evaluated for the purposes of the tracking. The tracking is just one way, input going into the telescope. Closed loop is where you have a video camera providing feedback into the program, and the tracking is occurring based on the feedback it's getting from the video camera. That's sort of the 30,000-foot view of control loop theory in 2 seconds. Yeah, they are going to be using a Dragon capsule on that SpaceX launch next week. So hopefully that goes smoothly. And the other news of the day on SpaceX is that they are planning to do their first reusable launch or reuse launch sometime in the very near future. They just tested the Falcon 9 rocket first stage that provided the launch of CRS-8, the CRS-8 mission with the Dragon capsule. That got tested over at the McGregor facility in Texas, and it should be reflying again in the very near future, in the next couple months. And I was actually at the launch for CRS-8, and that was the last NASA social I went to, so I got to see that rocket up close and personal. It's kind of my favorite SpaceX rocket because I was right there, just outside the last fence between me and the rocket. Yeah, sorry, it's cloudy for you there in New Orleans, and actually I'm coming up there in a couple months for a conference. But yeah, it's nice and clear here in Florida, so I'm glad to be able to provide these images for you guys, especially people who don't get to see it because it's too cloudy. right. We got 14% power, estimated 15 more minutes remaining on laptop power. In about 5 minutes, I'm going to plug in the laptop, and that may overload the battery that's providing power to the telescope, in which case that'll be the end of the webcast for sure. But I need to provide power to the laptop at some point so that I can collect the flat field images for calibrating these pictures after the webcast. Oh wow! Just saw either a meteor or a satellite flare. Oh, it's a satellite flare flashing off in the east. Wow, that is one hell. Okay, well, sorry about that, folks. Went from 15% power to no percent power in no time. It suddenly cut off. My computer shut down. So I plugged it in, and I'm back. Sorry about that. I think that's going to be the end of the active tracking for sure, because that would have interrupted the telescope communication. Yeah, let's stop and disconnect that. So let's just see here. go for it. So we'll take one more picture here and just see what happens. But I was too distracted by a flaring satellite, which made a really bright flash in the sky. It was blinking on and off as it was rotating. Some sort of space junk off in the east. And right when that happened, the laptop powered off. It overestimated its own remaining power when I checked it last time. So sorry about that. So at this point, I'm just going to do one more picture here just to see what happens. It's no longer actively tracking because of the power upset. Huh. Hubble Space Telescope passed overhead in about that area of the sky. I'd be surprised if that was a flare from Hubble, but because it looked like it was rotating out of control. It flashed a couple times that I saw. Huh. Could have just been glinting off a couple different surfaces, I suppose, but I don't know. If you hear a story in the news tomorrow about Hubble suddenly dying, then that's why. But I don't think that would be the case. It was probably just a reflection off of the solar panels at just the right angle. But it was bright. I mean, bright as Venus bright. Just a real brief flash from the satellite. But I saw it flare a couple times where it increased and then decreased in brightness. Oh, I didn't mean to do a subframe. Yeah. Anyway, that is actually the comet there. Now the stars aren't streaking because the telescope's just tracking on the stars. But I didn't mean to do a subframe picture. It only took a picture with the part of the CCD instead of all the CCD. Yeah, fantastic ending to the broadcast. Yeah, sorry about that. That was rather sudden. It didn't pop up the usual warning that said plug me in or I'm going to shut down. It didn't give me any kind of threat like that. It just shut down. I'm done. It's shut down. But now starting to see the twilight by eye quite a bit. So interesting to see how much of it shows up in the image here. Probably quite a bit. So there you go. Yeah, you can see a lot of twilight in this picture. It's washing out pretty bad. But the comet is just right here. Well, if your MLab is asking if they can see the comet because the moon's to their left and they're looking northeast at the horizon, well, I'm looking, yeah, looking northeast. Yeah, the moon's to your left. The comet is in Hercules. You're really going to need a finder chart. You can find a finder chart on heavensabove.com. Here, I'll drop a link in the video chat here. Heavens above. I'll just give you a direct link to the comet. So if you're in, I think you said you were in New Orleans. It should be visible there. This is a finder chart available on heavensabove.com. They've got charts of all the current bright comets, and you can see it there, where it is in Hercules. You're going to need binoculars to see it, or a small telescope. You won't see it by eye. It's too dim to see by eye. But yeah, if you've got binoculars or a telescope, you should be able to spot it. It's right at about magnitude 7, which, if you didn't have all this moonlight to deal with, maybe under exceptionally dark skies, you could just barely spot it with averted vision. But I'd be surprised if you could spot it with all the moonlight and now the twilight coming on. So just be aware of that. So we're going to be wrapping up the webcast here in a couple minutes, or possibly sooner if the telescope power dies, now that I've got the laptop plugged into the telescope power. But the twilight is washing us out here now anyway. The comet is just barely visible as a small cloudy object right here. Wow, you can see how much brighter the twilight is getting with every single picture. It's really picking up the pace. This might be the last picture we can even detect the comet at all. It's just right there, very faint, just barely brighter than twilight. So if you're just joining us, unfortunately you're catching the tail end. You'll want to watch the replay earlier where it was more obvious, but the comet is just a very faint little blur right here. And with the twilight setting in, barely able to detect it at all. This last picture that's coming in now, it may be completely invisible. So you'll want to check back on the replay to see it earlier in the broadcast, where it was a lot easier to see. We're just about to wrap up here for the morning. Gone. Gone. And that's it. That's all she wrote. But hope you guys enjoyed that, and stay tuned. I'll be posting a time lapse of all the images collected during this webcast. So stay tuned for that this weekend, and I'll be working on stacking these images as well to produce a nice still image of the comet. So thanks for watching. Please subscribe for more. This is Astronomy Live.